Hello, hello, hello. Welcome back to Mr. Taco's class on YouTube. I hope you had a wonderful, relaxing, safe, socially distant, masked up week off of school. And now we're in sort of that interesting period where we've got about 3 weeks in between this last break we had off and winter break. So it's actually a really good time to kind of focus on maybe something that, isn't like kind of the meat and potatoes of our learning, but is kind of like a special little kind of mini unit. And what we're going to be doing in math is talking about expressions, really laying the groundwork and laying the foundation for what eventually will be algebra once you get into middle school. Really exciting stuff. Here's what you're going to need. Something to write on, something to write with, the usual stees. And down here are our I cans today. I can define a mathematical expression as a mathematical sentence without an equal sign. We're going to talk about that in our intro. And I can create an expression based on a computation sentence. Now, before we get into kind of what expressions are and how they work, let's establish some vocabulary first. And to do that, we're going to need a word wall. Look at that. There it is. Amazing, right? So the first thing we want to talk about is this idea right there of an expression being a mathematical sentence without an equal sign. Okay? In its simplest terms, right? That's all it is. But the reason why this gets important is because once we, and we're going to do this week, introduce the idea of a variable, a number or a symbol representing a value, then it becomes a little bit more important to sort of have this expression kind of by itself. Okay? You might have heard the term equation. Let me move the word wall just for a second. You might have heard the term equation before, right? An equation is essentially two expressions of the same value with an equal sign in the middle. In the middle. Okay, so this equal sign really thinking about the same value is going to be on the left as is going to be on the right, right? 32 plus 7 equals 41 minus 2, right? This is an equation, okay? Essentially, two expressions. 32 plus 7 is an expression by itself. Solving that expression, right? And you can write it as an equation where you've got sort of the most simple form of this would be to add 32 and 7. And then it would equal 39. Or subtracting 2 from 41. And that would equal 39. Okay? This equal sign, we want to get out of the habit, I think, as emerging mathematicians. We often think about the other side of the equal sign being the answer, in big air quotes, the answer. Really all it is, when we're thinking about the equal sign and filling in the unknown on the other side of an equation, what we've really been doing is simplifying an expression to its kind of most simple form. And we're going to talk about simplifying expressions later in the week. But just for today, we really want to think about an expression, and I'm going to pull up my word wall again here. We really want to think about just an expression being a mathematical sentence without an equal sign. So this idea of 32 plus 7 is an expression, right? 18 times 18, right? That's a mathematical expression, okay? Now, we're not actually going to be in the business of simplifying equations today. We're not going to be in the business of this one right here, computing or calculating using mathematical operations. We're not going to be in that business today. Okay? We're going to worry about simplifying equations tomorrow and Thursday and beyond. Just today, getting this concept of an expression is just kind of a math sentence or a number sentence. Okay? Doesn't have an equal sign because we're not worried about finding an equality here. We're not worried about having another expression on the other side that has the same value. Just today, we're worried about that. Okay? And other math vocabulary we're going to need here is our sum, our difference, and I'm going to put whoops, there we go. Oh, come on. Oh, that's why. I'm going to put a space in between that difference in product because it's going to bother me. There we go. Okay, and the other math vocabulary we want to think about today are these three here. Okay, sum, difference, and product. We've heard these words before when talking about addition, subtraction, and multiplication, but they are important in helping form and create expressions. So if you hear the word sum, if someone's asking you for the sum of 185 and 17, right? In this case, today, we're not actually asking to solve that, okay? I don't need to know what the most simple form of that expression is, which is kind of just a number, right? But the sum of 185 plus 17, how are we going to write that, right? 185, we know with a sum, we're talking about addition, plus 17. Okay, that's our expression for that. Our sort of computational sentence is kind of what I just gave you in words, right? 185 plus 17, or the sum of 185 plus 17. Okay? Somebody says in the chat, should it say 2 or more add-ins because 34 plus 211 plus 88 has some? Yeah, yep, it should. Yeah, it should. Good catch. Hold on. Or more add-ins. And ta-da! You were so right. Look at that. Editing in real time. Beautiful. Yeah, 2 or more add-ins, right? If it was the sum of 185, 17, and 47, right? Still using that plus sign, right? Difference, finding the difference between two numbers, right? What's the difference between 88 and 74? Okay, that we use subtraction for, right? Here's 88 on a number line. Here's 74 on a number line. What's the value of the distance in between those two numbers, right? That's our difference, right? And then the product, the result of two factors, 2 or more, again, 2 or more factors being multiplied together. Okay, so, you know, finding the product of 8 plus 2/3, right? Doesn't have to be a whole number. Finding the product of 8 plus 8 and 2/3 would be 8 times 2/3, or 8 times 2/3, right? We can use the dot in the middle just like we can use the x. And actually, we're going to be using the dot in the middle more often because once we get into variables, x kind of becomes a variable. We'll talk about variables later in the week. You might have heard that term before, but we'll go more in depth. Don't worry about it today. Let's go to our digital whiteboard, and we're going to practice writing some expressions. So our first one says this: the sum of 2/3 and 3/8. Now, reminder, just for today, we're not in the business of, I actually don't want to know what the sum of 2/3 and 3/8 is. I want to know, can you turn this computational sentence, computation with words, can you turn this into an expression using one of our operational signs, our plus sign, our minus sign, our x or our dot, or our divide sign, or slash, really, if you want to get theoretical about it. The sum of 2/3 and 3/8. right? So thinking about that vocabulary with sum, meaning we're going to add. So we need our plus sign, 2/3, and 3/8. And that's all. Okay, we don't need an equal sign right now because we're just worried about the expression. Okay, it may seem like, oh, this is easy peasy, right? But once we get into variables, right, and now it's not the sum of 2/3 and 3/8, but it's the sum of 2/3 and y, 2/3 and p, okay? And we get into multiple operations, okay? It's really important to have this idea down, that the first thing you do before you worry about simplifying it and solving it, okay, is just to write it out in these mathematical terms, okay? 2/3 plus 3/8 is the expression that matches the sum of 2/3 and 3/8. Let's try one more. Subtract 19 from 74. Okay, how are we going to write subtract 19 from 74, right? We've got the word subtract in there. Okay, right? Easy peasy, right? 19 minus 74. Dunzos. Easy, right? Wrong. Check for reasonableness here. What did we just do? Read your sentence again. It says subtract 19 from 74. And in this case, we're actually subtracting 74 from 19, right? We're taking, in my incorrect example, I've taken 19 and I'm trying to take 74 away from it, okay? So this is where really making clear, okay, subtract 19 from 74. So really thinking about it in those logical terms. Okay, if I'm taking something away from something else, right, I have to start with my 74, and then I have to subtract 19 from it. Okay? In subtraction and division, order matters, right? Which one comes first, which one comes second. That drastically changes what happens when you try and simplify this expression, okay? Addition and multiplication, because of that commutative property, right? Our addends can stay the same, or addends can change and our sum would stay the same. Or our factors can change and our product stays the same. Not true of subtraction and division. Make sure you're starting with the right number, okay? And I see this often too. If you were to take 74 minus 19, right? And someone would try and tell me that like 4 minus 9 is 5, right? Not quite. You can't do 4 minus 9. You've got to regroup, okay? So making sure we're going in the right order is going to be important. That's coming up tomorrow, in fact, okay? I do want to try one more because it can be tricky, particularly with subtraction, when we get into something that looks like this. The difference between 183 and 262. Now, this is a situation where, unlike the last example where it says subtract something from something, where it gives you the order, here we've got to think about the difference between these two numbers, okay? And this is where your comparing comes into play, because in order to subtract, because we're not dealing with negative numbers yet, in order to subtract, okay, we've got to make sure we put the number that has the greater value first in our subtraction expression. Okay, so which one, 183 or 262, is greater? You're not saying in the chat, but I know you're thinking about it because I can read minds. 262 is greater than 183. So we would put that one first in our expression, and it would look like 262 minus 183. Okay, so kind of an intro day today. Where we're not, really, we want to get ready to ramp up the rigor when we start with order of operations, having maybe multiple operations in one expression, right? Tomorrow, you might see things like, the sum of 476 and the product of 8 and 12 in one expression, right? What would that look like? Okay, we're going to talk about that. We're going to talk about how order makes a big difference when you have multiple operations in one expression. All right, and we're also going to introduce some variables this week of being able to say, the difference between the product of 17 and x and 45 and g, right? What would that look like as an expression? Again, not super interested in solving them yet, okay? We're focusing on the setup, because if we don't have the setup, it's very, very hard to solve things, okay? But if we have our setup down, if we have our ability to create expressions, write expressions accurately, then solving them and simplifying them will be a lot more straightforward. All right, everybody, thank you for tuning in. Our exit ticket will be on Google Classroom shortly if it's not there already. And remember, the Math Office Hour Zoom room is open promptly at 11 o'clock and will be open from 11 to 11:30 if you have any questions on today's lesson. Thank you for tuning in. Happy math, and I will see you soon.